Well, let's see how the Spectral Spatial scan mode works in the EMViewer from Y.I.C Technologies. We will be working with the EMScanner, and we have a prototype on top of the surface of the scanner. This is a top view, and we are interested in finding what kind of emissions are coming from the device under test, and not only at what frequencies. We want to see where those frequencies are located. The first step is to go to the project menu and open a node that we call a Spectral Spatial node. We specify the frequency range of interest, for example, from 10 MHz up to 110 MHz, and we will use a resolution bandwidth of 120 kHz. The second step is to specify what cells are of interest for my scan. I am going to specify the cells that are just below the device under test. So we take from this cell to this cell and we activate the cells. In the overlay editor, we will be able to introduce some kind of drawing or picture, or like in this example, I am going to put the Gerber file. I can mirror vertically and I can rotate, so I can adapt exactly the drawing to the size of my PC board. Then I can accept. I am ready to start the test. In the left side, you will see the spectral results. In the right side, you will see the spatial results. I can make a zoom, and then we can see how the scanner is going from cell to cell and scanning from the first frequency to the final frequency. In red color, we see where we have more activity, and the colors change as we progress in the scan process, because the red color will be associated to the maximum amplitude, and this is changing as we go over the full area of the scan. We will be able to change how is the scale in colors, or we can add or remove the overlay if we are interested in looking more or less detail of the scanning process. Look at this. I am locating different harmonics that are coming from my circuit. In this circuit, I have a crystal that is related with the clock frequency for the microcontroller. It's a crystal of 11.06 MHz. This is the first harmonic at 11.06 MHz. And if you move the mouse around the scanning results, you will see that the frequency is different, because for different cells, the maximum amplitude can be of different frequency. When we have finished the scan, we can combine the spectral with the spatial view. For example, we can go to the user composite view. We will obtain here a frequency list, and we specify in the spectral view what kind of frequencies are of interest. For example, I am going to select the multi-frequency marker selection, and we can specify the first harmonic. We can go, for example, to the third harmonic. Third harmonic. And we can go to the fifth harmonic, and then we can go to the seventh harmonic. Something like that. You can introduce as many cursors as you want. Okay, let me try again. Here, okay. So this is the 11, 33, 55, and 77 megahertz. When you are ready to see the results, you can unselect all the frequencies, and you can see where is the first harmonic. It's coming basically in this area here, around the microcontroller and the crystal. But for example, if we specify the fifth harmonic, we can see that it's located in a smaller, in a closer area, close to the crystal. No? Let me remove again the 55 megahertz, and let's go to the 100 megahertz. So we can identify how is the path for the first harmonic, and we identify some kind of current coming in the edge of the PC board, perhaps creating some additional problem. No? In the 55 megahertz, the activity is concentrated closer to the crystal. And this is the spectral spatial view, very useful for debugging EMI problems in your circuits. I hope you enjoyed the video, and see you in a future video coming soon. Bye bye.